Right.
Okay, great. Hello, my name's Dan, and today I'm going to show you how to conduct, or one way at least anyway, how to conduct the aeroplane lesson within the Forces unit of physics. This is a lovely lesson, and the whole objective here is to allow kids the opportunity in which to plan an investigation, but there's plenty of extension opportunities into analysing data, generating data, recording data, etc, etc. So depending on where you want to take this lesson, you can focus, and it'll become self-evident where you can do this. Okay, so you've got all the apparatus. We can start now. If not, now's a good time to pause the video and take a little break. Anyway, I'm going to crack on. Okay, as soon as you mention the word aeroplane, the kids are going to go berserk and they're going to go, oh, I can do an aeroplane, and you want to calm all that down and just say, just for the sake of this particular first lesson, we're going to do one aeroplane to start with, and everyone's going to do the same thing. So, without much further ado, this is how you make a really robust, superb little aeroplane which works perfectly for this lesson. It's taking you one sheet of A4, and everyone can make one of these. Have the whole class do it, it's the easiest way to do it. You fold it straight down the line, and it's really important that you make all of the lines absolutely symmetrical, or folds rather symmetrical, and all the lines really crisp, nice and sharp. So the first one then is straight down the centre like so. You've probably done this a million times, but just for the sake of continuity, you then fold over the two parts of the nose, and that's your second little set of folds. Now the next bit here seems a little bit unusual, but you're going to fold the whole of this nose along the line that it naturally forms into the paper, and again along the centre of the paper, like so. That should be your third fold. Okay. The next one causes a little bit of consternation. It takes a little bit of time for the kids to work out. The easiest way of doing this is get a pen or a pencil or something of that nature and put a little dot about a thumbnail length into the nose like so. And you're going to use that as the focus for both of these particular points. Now you're going to have to fold that and manipulate the paper here in towards that little dot. Like so. So you get a rather snub-nosed look and a rather neat little sort of fold like that. Now these little things here, you're going to trap those by folding this end of that point of the nose up like so. Okay, so make it again nice and symmetrical. Alright? Again, you want to go around the class and make sure everybody's done this, because effectively they often miss this particular part out. Now if you hold the plane like this and get the whole class to do this so they get it right, you then fold the plane back on itself, okay, like so, until you've got, as you can probably see, a plane coming out, and depending on how crisp your folds were and how accurate you were, you'll have a symmetrical plane. Now this next little bit is the last little bit, which is of any trickiness, is you're going to fold the whole wing in parallel to the base of the plane. Dead easy, but just basically get the wing like so. I fold that in parallel to the base of the plane, and then repeat on the other side. Like that. And here you have a perfect little flying machine. Okay? So that's stage one, that's the most difficult bit, so everybody have that, and of course you're going to have to emphasise to the class LT students that they shouldn't have any illicit flying lessons beforehand. They'll get the grip of it fairly quickly. So that done, that's the basic nub of the lesson. Okay, the demonstration one is a demonstration thought process here, which kids really like. And what I like to do is imagine that you've got a magic wand. Okay. Now this is one of the wonderful areas of physics where right from the very beginning all the way up to a very advanced level you can introduce a concept in physics and concept in science, which is absolutely awesome, which people still don't know, cannot explain why. We can explain like magnetism, lots of reasons behind it, and analyse it in lots of different ways, but cannot explain why this particular process happens. So what I want to do, now I haven't got a seat here, but if I had a seat, what I tend to do is I would stand on a seat, and I have my little magic wand, and I say to the kids, right, imagine what would happen if I'm waving the magic wand, and the seat suddenly disappeared. And it goes, you fall to the floor. And you go, yeah, great, I fall to the floor. Bang! And so you fall to the floor, that's great. But why do I fall to the floor? And somebody hopefully will say, oh, gravity, that's great. So you're not actually falling, gravity is pulling you down, which is great. So you get that general consensus of agreement. And they say, great, well, I'm on my magic wand again. And normally when I'm conducting this, and I'm conducting a lesson on the third floor or somewhere, I'll say, right, now wave my magic wand, and the whole building disappears. What's going to happen to me now? And eventually they'll say, you're going to fall down to the ground. That's absolutely right. You're going to fall down to the ground. So gravity is going to pull you down to the ground. Fairly quickly, of course. Okay? So that's great. Everybody's happy with that normally. And then what you say, right, with your magic wand, finally, if I wave a magic wand and I wave the wand and the earth disappears, what would then happen to me? Now that usually causes the class to stop. And it's really important to understand that they've got to come to an observation. If you don't, you've got to help them to that. But actually you would keep falling. You'd keep moving. And you keep moving in that direction. Now in space, of course, there's no north, south, east or west, but you would keep moving in the direction, that direction, down, in this case. And no one knows why. Everything moves. Everything moves. And we don't know why things move. So Sir Isaac Newton, and this is really important actually, it's a lovely opportunity to introduce a really nice famous scientist. When I say nice, he's the most appalling scientist that ever lived, but he was one of the cleverest people that's ever lived, and it was him that first of all discovered this particular process and defined the laws, the 3 laws of motion. And now it's an interesting, a separate lesson to introduce Sir Isaac Newton. Okay, so that's the demonstration. And it usually takes kids a little bit of time to work that out. Okay, so what you do now then, in terms of the lesson itself, there's lots of ways you conduct this, but you go through, as you've seen in the introduction slides, the planning sheet. Now in the planning sheet you will have walked through all of those particular aspects of the independent and dependent variables. They've got a plane, and of course you've drawn out from them what it does. It flies. So if you then say, well look, I've got a whole bunch of these, you can get from them, what are we going to measure and what can we change? And of course with these and with that you can change the mass and you can measure how far it flies. But of course you could change the type of paper, you could change the colour of the paper, not that's going to make any difference potentially. And you could have a stopwatch, you could measure time, you could time of flight, you could go how high, you could go all these kind of things. They're all viable, and you just put those in words, and they get to do that later. But so draw them, guide them, as it were, gently into the fact that what we're going to do today, the easiest thing to do with your meter rule and with these, is you're going to change the mass, and you're going to measure the distance it goes. And what you then do, of course, is you get them to put it into a little grid and measure it 3 or 4 times. They've got to throw it 3 or 4 times with, let's say, for example, 1 paper clip. And of course they're going to ask you all sorts of questions, which you never answer really. They can say, I wish I put the paperclip now. They're the scientist, they work that out. It's for them to decide, because they've got to come back and then evaluate whether or not that was the right place to do. But just for the sake of this presentation, I've stuck it there. So in their little graph they would have, or their table for example, they'd have 1 paperclip, then distance 1, throw it, measure it as precisely as possible. So one person standing here and then measuring it precisely with your ruler, and then repeat it. And that basically is the lesson. So you can come back at the end of the class, you've got your 1 paperclip, your 2 paperclips, etc, etc, etc. You nicely little table, and you can produce a lovely little graph there. Obviously on the x-axis are the things you control, so that's your independent variable, number of paperclips, and the y-axis is the distance, okay? And that's it, it's a lovely lesson, it goes like a bang, quite literally, and that's it. Thank you very much for listening. Good. Just, just press that. No.